began our discussion, our review of these, for lack of a better word, parent graphs, right? This is a parent graph with a base of 2. This is a parent graph with a base of 3. This is a parent graph with a base of 4, right? And we're going to perform transformations on those. So this one is this. Next one's green. So same thing. So I'm going to go over 1, but this time I'm going to go up 4. 1, 2, 3, 4. And when I go to the left one, I'm going to go a 4th. Are we seeing the connection? Don't be against it. Be open. Like this. Like this. Right? Okay. So when I go over 1, I'm going to go up 5. 1, 2, 3, 4, 5. When I go to the left one, I'm going to go up a 5th. Yes. If I were to go over 2, I go up 25. 5 squared is 25. Okay? If I go over 2 on this one, I'm going to go up 16. Okay, so now let's perform some shifts. So let's do a shift of +2, +1. If I do a shift of +1, hopefully I did this right, this should go up 1. Same points, it's just up 1. Right? I kind of pretend like I now have an x-axis at, let's do this. I kind of pretend like I now have an x-axis at, my x-axis has shifted up 1. I could have graphed it exactly the same from here, right? 0, 1, over 1, up 2, over 2, up 4. Right? We're just pretending like we just took our bottom line and put it up 1. It is an asymptote. Exactly. Okay. We kind of have 2, but technically this asymptote is that the graph can never touch it. But this asymptote is kind of a fake asymptote. It guides us as we shift, but my graph can touch it. That's why we can't call it an asymptote. Does that make sense? Yeah. What? The vertical asymptote is never affected in the equation, right? It just shifts the origin of our transformation. It just shifts it. That's it. Okay? So let's do one of those shifts. So let's do a shift of -1. My question is, again, for sure. So like for x, like x is 1, and is our exponent going to be 0 then, because 1 minus 1? We're not going to talk about tables right now. I'm not going to talk about tables at all. No, we're just, no, it's not. No, it's not. It's putting in a value for something and getting an answer. It's a table. Okay, we're going to table that. I'll come back to it, but I don't want to shift everybody's thinking right now. I'm controlling the thinking, and we're doing transformations. I'm tabling the table, okay? All right, so if I have a -1, that's a transformation to the right one, right? This way. So I'm just going to take it, I'm going to move it. Let's actually move our pretend, we need to come up with another name for it, our pretend asymptote. Our guiding line? Our guiding vertical line? I don't know. I'm open for options, guys, because it's not an asymptote. And when you get to a math analysis and you call this one an asymptote, they're going to go, who was your last teacher? Why did you teach that? Okay. So right here, I'm going to shift it to the right one. So my y-axis is now going to be to the right one. My asymptote on the x-axis is still there. So it's like my origin has now shifted over 1. Shift to the right. So my graph is going to be the exact same graph. It's just shifted over 1. Is your K. Got it? All right, let's do the green one. Are we doing better? Lama. There isn't. There isn't another one. I mean, what basically happens is it's not an asymptote, but basically on this one, if I go to the right of it, the numbers are going to get bigger. And if I go to the left of it, the numbers are going to get smaller. Okay, so this one, what do you guys want? You guys want to do double? Ooh, let's get crazy. What transformations do you want to do? What? Scale factors next. Okay. Let's do plus 2 and then minus 3. Yeah, so that you can see it. You like that better? So my x. So I'm going to go to the left 2 and down 3. So I'm going to draw that new. So hold on. Let me complete it. So we're going to go to the left 2. Right? Let's make that a little bit darker. To the left 2. And then down 3. 1, 2, 3. I'll do this one and this. Down 1, 2, 3. So there is my new origin. I'm going to put black on it right here. There's my new origin. And I'm just going to graph it. Let's graph it, and let's make it bright, something else. Let's make it a darker green. Yeah? Okay, so if it has a base of 4, it always has 0, 1, right? And then we're going to go over 1 and up, 1, 2, 3, 4. And over to the left, and how much up? 1, 4. I was over 2. All right, so it's the same graph. It's just shifted to the left 2 and down 3. Yes?
So, the x plus 2 up there, that doesn't affect the actual x plus. I know it's not your table, but because that was my problem, was I didn't know if I could just build it like how you did.
I want to table the table conversation because I have something for you, but I don't want to talk about it right now. But let's table it. Because I don't want to go there right now, because I'm going to take everybody's thinking and I'm going to shift it, and I don't want to do that. Because right now, I have to go to stretches, and I don't want to talk about, I don't want to shift everybody's thinking. I feel like we have these great conversations, but then we don't get to the end of it because I let them go, and sometimes I need to, Miss Liz told me this, she gave me a suggestion on teaching, and she said, sometimes you've got really great questions, you've got some really great kids, you need to have like a table of let's table this, okay? All right, because I start getting sidetracked, and then she's like, then you start losing other kids, and so that's what's going to happen right now. So that's what I'm going to do. All right, so I'm not going to do the last one. I think we're okay. So let's move on. All right, so describe. This is our horizontal. Let me change this color back. This is our horizontal, right? This is our vertical shift. Now we're going to talk about A, our stretch. Sound good? All right. So I want you guys, first of all, to explore it a little bit. Remember, we're going to ignore this. My goal for you right now is to put this stuff, oh, that doesn't work very well. My goal for you right now is to investigate what happens with the stretch, okay, using Desmos. Investigate what happens with that stretch. I want you to put, like for instance, with this one, I'd like you to put into Desmos, let's see, let's do it in blue. I'd like you to put into Desmos 2 to the x. Right? 2 to the x was 0, 1, over 1, up 2, over 2, up 4, over to the left 1, a half. See what happens in Desmos when you throw 3 out in front of there. Okay? So go ahead and use your phones, or you can go ahead and use Chromebooks. Let's do this for about 5 minutes. So what you should have discovered, you nice pink for this one. So what you should have discovered is that what this number does is it stretches it by a factor of 3. So instead of starting at 0, 1, right, I'm going to go 3 times that, which is 1, 2, 3. And instead of going over 1 up 2, I'm going to go up 3 times that. So 3 times 2 is 6. So over 1 up 1, 2, 3, 4, 5, 6. And instead of over 2 up 4, I'm going to go 3 times that, which would be 12. Make sense? So over 2 up way up there. In the reverse direction, over 1 up a half, what's 3 times, so I'm going in the negative 1 now, what's 3 times a half? 3 halves. How much is 3 halves? Well, count it. 1 half, 2 halves, 3 halves. 1 1/2. Alrighty? Are we good? Three, 6. Where? Here? 3 times 1 half? This is why I don't want you to use tables. I don't want you to make these mistakes. So 3 over 1 times 1 over half. You have a really good knowledge of algebra 1, and I don't want you to mix up any arithmetic errors. You know what I mean? Okay. Do you see what I mean now? Good. All right. So, what do you think the negative is going to do it? It's going to make a reflection over the x-axis, right? So instead of going, I'm going to graph it. So I'm going to go 0, 1, right? But I'm going to go 3 times that in the negative direction. Make sense? So instead of going 0, 1, I'm going to go 0, negative 3. Okay, so here's the hard part. All right. So is this going to go like this? Or is it going to go like this? Let's try and figure out why. No, the best way I can explain it without using a table, which we will get to, the best way I can explain it is that I'm still going to the right one because I'm talking about a growth function. Does that make sense? So normally I would go right 1 up 2, but I'm going to go 3 times that, so I'm going to go 6. Nate, whatever you're on, close it. You're a dead giveaway. So he has no poker face. You should play poker with him, okay? So instead of going over 1 up 6, I'm going to go over 1 down 6. 1, 2, 3, 4, 5, 6. So you have in your head, right, what the parent graph should be, which should be 1, 2. And you say to yourself, but I'm not going to go 2, I'm going to go 3 times that. 3 times 2 is 6. And so I'm going to go negative 1 and 3 halves. 1, 2, 3 halves. And that's what it looks like. All right, are we good? One more? All right. So what happens here? Did you guys figure out what happens here? It goes to decay. So instead of being this negative, turns it into a 3 to the 1/2 to the x. Is that true? You could write it either way, right? So basically you're using the same numbers, like those magic numbers we always talked about. We're using the same numbers, only we're going in the left, the decay direction. Okay. So this one, I'm going to go 0, 1, but instead of 1, I'm going to go 3 times that. This time, instead of going to the right 1 and up to times 3, which is 6, instead of going over 1, up 6, I'm going to go to the left 1 and up 6. 1, 2, 3, 4, 5, 6. And before, when I went to the left, I went those 3 halves. Now I'm going to go to the right and go up 3 halves. Starting to see the pattern? It's all the same thing. Try this one on your whiteboard, and then I'll do it. Or you can do it on your desk if you'd like, whatever you'd like. But you try that one, and then I'll confirm whether you did it correctly or not. Fun. Okay, so this is what yours should have looked like. So I'm going to rewrite this. It's a negative 3 with a base of 2 to the negative x. Well, if I don't like to look at it like that as a negative x, I mean, do you guys like that better than the fraction? It just means reflected over the x-axis? No. This means reflected over the x-axis. This means reflected over the y-axis. So it's just preference, okay? The fraction confuses you? Yeah, because it really is. It's the same thing as this. It's the same thing as 2. It's just go to the left instead of go to the right, right? Okay, so for this one, I would normally go up 1 from 0. But instead, I'm going to go up 3 times that, which is 1, 2, 3. But instead of going up 3, I'm going to go down 3. That's my starting point. That is my new vertex. Okay? Or my major reference point. My next reference point is going to the right one. Normally, I would go to the right one up 2. But instead, I'm going to go to the right one up 2 3 times, which is 6. 1, 2, 3, 4, 5, 6. Only this 3 tells me I'm going in the negative direction 6, which is 1, 2, 3, 4, 5, 6. But the negative x tells me I should be on the decay side, which is on this side. Alrighty? Okay. So now my next magic number is if I normally go to the left 1 and up a half, but this time I'm going to go to the left 1 and up 3 halves, but we're going to go 3 halves in the negative direction and on the other side of the y-axis. Basically, you really only need 3 points for these. 4 is better, but if a lot of times when you start applying a stretch to it, you're never going to fit the 4th on a graph. Make sense? Okay. Christiana, why don't you put your backpack on the ground and give your full attention to math right now. Jaden, please don't ask me if you're going to ask me if, please don't tell me you're going to ask me if this is going to be on the quiz.
No.
Okay.
I was going to say something on school.
Oh, on school. Yes. That is a good question to ask. All right. So let's put it all together. You ready? No? Okay. Let's stop all this talking and do it. I like it. So what type of transformations would you guys like to see? All of them? Okay, what do you want to put for A, for the stretch? 2. What do you want to do for a horizontal transformation? 4. X plus 4 or X minus 4? Minus 4. And then what do you want to do for vertical stretch? I mean vertical transformation. Plus 3, I like it. I don't know. Minus 4 plus 3. Is that good, Kane? Awesome. All right, so my first step is to make those vertical and horizontal transformations, like making a new origin. That's the first thing I'm going to do. So I'm going to get, I think I'm going to do them in green. Purple, because I'm not going to get to that one. Purple. Okay. So I'm going to shift to the right 4 because it says -4. So I'm going to go over 1, 2, 3, 4. And then I'm going to go +3 is a vertical shift up 3. So up 1, 2, 3. There is my new, we should have gone -3 because it's not going to fit on the graph. Right? And maybe not what? Okay, hold on, guys. These are little graphs, so we're just going to have to improvise and go to our homework. How's that sound? Okay. So instead of going +3, I'm going to go -3. Down 3. 1, 2, 3. So does everybody understand we now have a new origin that we're going to work off of? So normally I would go over 1. Sorry, let's do our first reference point. Normally I would go up 1, right? 0, 1. But instead of 0, 1, I'm going to do that 2 times. Correct? So I'm going to, instead of going 0, 1, I'm going to go 0, 2. 0, 2. Normally I'd go over 1 with a base of 2. I'd go over 1, over 1 up 2. But instead of going over 1 up 2, I'm going to go twice that. So I'm going to go up 4. So over 1 up 1, 2, 3, 4. Normally I'd go to the left 1 and up a half. But instead of going a half, I'm going to go twice that. How much is 2 halves? A whole, right? So to the left 1, up 1. I'm a firm believer in working backwards. I think if we work backwards, you guys will get this more. Let's work backwards. I think I have one in here, but I think I'm just going to create one. Okay, let's do this. Okay. All right, can you work backwards? Yes. Okay, so I have y equals, I have an a out in front, right? I have a base, and I have an x, and I have a shift, and I have another shift. What? I'm going to tell you right now, and this is what I'll do on the test as well. I'm going to give you the base. All right? The base is 3. I'll give you the base. I'm not going to make it too tricky. The base is 3. All right, so you should already know this number right here. What is it shifting? This one here. 1, 2, 3, 4, 5. So I'm going to switch that to a positive 5. And then I went down 1, 2, 3, 4, 5, 6. So that's going to be a negative 6. And then what's my stretch? Instead of going 0, 1, I went up 1, 2, 3. So my stretch, let's double check. Right? I think I did this one wrong. I did. I meant to make this one here. I meant to go up 4. 1, 2, 3, 4. Right? So then this one, when I go over 1, instead of going up 3, it should be up 12. And I think that's what I did. Over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is, in fact, 4. My stretch is 4. Sorry, I had to do that one off the top of my head. I think I have another one in here. Yes. Brett. No, we are not. We're not going to go that far. We got there? Yay. Okay. Okay, here's one. This one's hard. You know why it's hard? Yeah, I'm going to come back to this one because I don't want to confuse you too much, because you can definitely figure it out, but I'm going to add another reference point to it, and then we can figure it out tomorrow, okay? All right, so let's get into our homework, and then as promised, I said I would go back to those tables. So if you want to listen to the tables, you're not doing tables? Okay, you don't have to. The homework is the backside. Yes. I wouldn't use Desmos if I were you, because you can't use Desmos on the quiz or the test. So I would just, if I were you, I would use Desmos to check to see if you're correct or not. Yes. What? Can you what? Yes, I can. Yes, you may. Okay. Let's use some tables. I'm just going to use a fresh page. Okay, Aaron, you ready? I do. I think I do. You'll know in just 1 second. Okay? All right, so let's do something like, this. Normally your table would start at 0. You'd go 1, 2, negative 1, negative 2, right? But when you start putting numbers in there, you start getting fractions, weird numbers, and you get frustrated. You're like, okay, I don't know what I'm doing. Okay, so this is what you need to do. You need to understand the transformation. So this transformation is to the right 3, right? This transformation is to the right 3. So if I go over 1, 2, 3, that's your new 0. So your new 0 should be 3. And your next 1 should be 4. And your next negative number should be 2. Right? What?
We're on the right track.
I know what you're talking about, right?
Yeah, because then to find the y, so when x is 2, so we plug in.
So when x is 3, you should get 1.
There we go.
Yeah.
Yeah, so my question was, is it independent? I knew that it affected the shift. I didn't know if it affects the shift and that. Finding y.
the way I do it if I have to do a table is I think about where's my middle ground, where's my starting point. My starting point is shifted to the right 3.
Yeah, and then that's just, and that's why I was like, well, how can you not do it like thinking that way? And then you think I have like a little table in my head. That makes any sense. And I just didn't know. Like,
So if you insist on doing tables, you're going to have to make your mind shift this way.
Or I also didn't know if, let's say x is 3. I didn't know if I had to do 2 to the 3.
No, you take care of the exponent first.
Yeah.
So 3 minus 3 is 0, so it's 2 to the 0, which makes 1.
Okay, and that's thank you.
You're very welcome. Did anybody else need that? Do I want to table it? No? Nobody cares? Okay. It's okay. So Andrew has a question on which one? Well, you got to tell me what it is. Okay. All right. So my base is 3, but this negative x can be written like this. Negative exponents are positive fractions. So we know this is a decay graph. So instead of going over 1 up 3, we're going to go to the left 1 up 3. Okay? Make sense? Okay, I'm going to do this when we also need to talk about the domain, the range, all that stuff. So I'm going to graph this one really quick. So when I graph this, I'm going, I don't have any horizontal or any vertical shift, right? So we're just going to go, normally I would go 0, 1, but I'm going to do 2 times that, so it's going to be up 2. Normally I'd go over 1, up 3, but I'm going to go twice that, 3 more, but on the other side. Normally I go to the left 1 and up a third. I'm going to go 2 times that, which is 2/3, but I'm going to do that on the left side. So there's my graph. What are our next questions? Reference point. My reference point is 0, 2. It's like my vertex. Asymptote. My asymptote is still on the x-axis, right? So it's where y equals 0. My end behavior. As x goes to infinity, what's my graph doing? It's going to 0. My graph is going to 0.
I know this is going to touch 0, but it's in that direction.
Exactly. As x goes to negative infinity, what's my graph doing? It's also going to infinity. Domain. Domain. As I go to the right, my graph is going to keep going. All my x values are going to keep going. They're never going to stop. As I go to the left, all my x values are going to keep going. Y values. Range. My y values are everything. As I look on my y-axis, my graph is going to go everything up, but it's going to stop at 0. So y has to be everything greater than 0. What if this was f of x equals 2 times 1 to the third to the x minus 4? How would that change this? What would my new range be if this was negative 4? Yes. Christiana. I can't hear you. Is it 1/6? Is what 1/6? here. This one, negative 1, 1, 2, 3, 4, 5, 6. Yes, it is. Negative 1, 6. Okay. Why is it negative 1, 6? Okay, let's go back to it. So, normally I would go with a base of 3. I would go over 1, up 3. Because 3 to the 1 is 3. But I have 2 of those. So I have 6. But I have, this is decay, so normally I'd go over 1, up 6, but it's decay, so it's on the other side of the y-axis. I still can't hear you. You multiply by 2. That's what this means. Multiply means whatever my function is, I'm multiplying it by 2. If it was a 3 out here, I'd multiply it by 3, and I would have 9. It'd be over 1, up 9. Why don't you have anything in front of you? I took your paper. There you go. So, what happens when I change this to negative 4? How does that change my range? If I drop my asymptote down 4, 1, 2, 3, 4, how would that affect my range? What would my range now be? Y would have to be greater than negative 4, right? If my whole graph shifted, y would have to be greater than negative 4. Okay. I'm just going to let you guys work.